I'm going to show you how to find conditional probabilities and how that all works with given sets. What I have here is a die. It's a picture of a die. Everyone knows what a die is. It's a six-sided dice or die, 1 through 6. And they all have equal probability of landing on any side of that die. So we have two sets that I'm going to be working with this die. Now the sample space for the die, we know the cardinality of the sample space is equal to 6 because there's 6 different possibilities. So that's our sample space, S. The cardinality of S is 6, but the actual elements of S is equal to this set here. It could be 1, 2, 3, 4, 5, or 6. Hence the cardinality of S is equal to 6. What I'm trying to figure out is, let's start with the probability of event A happening, any event in A happening. The equation for the probability of event A is going to be equal to the cardinality of A divided by the cardinality of the sample space. And we already said the cardinality of the sample space is 6. There's only 6 possible outcomes. So how many outcomes are in A? Well, there's 3. We can count them up. The cardinality of A is 3. So it's very simple. 3 out of 6 chance, or a 1/2 chance, that if you roll this die one time, you're going to either get a 1, a 3, or a 5. That makes sense because there's numbers 2, 4, and 6, and it is half of the sample space. So you would suspect that 1/2 or 0.5 is the probability that event A would occur. Now, well, I'm going to show you another thing that we're going to learn is find the probability of A occurring if, in fact, B has occurred. So you know that B has definitely occurred. If that was the case, what are the chances that A also occurred? So, in simple terms, if B occurred, that means that the die was rolled and it landed on either 1, 2, or 3. So that's a given. This did, in fact, happen. When you write it out like this, it means B occurred. So it's definitely one of these numbers. Knowing that B occurred, what are the chances that one of these numbers happens to be one of these numbers? So that would be the intersection, basically, right? So let me give you the equation of P of A given B's event. Well, let me start out by giving you the general form here. It is A intersect B, all divided by the cardinality of B. And I'll show you why that happens in a moment. Okay, so the intersection of A and B divided by B. What essentially is happening is your sample space is now B instead of S. So if you look at this example here, you have the probability of A occurring in the entire sample space. This formula is showing the sample space is actually just B, because we know that B did occur and we know our sample space is now limited to this area. And so what intersects between A and B? If you do that, so you have 1 and 1, they intersect. 3 and 2 do not, or actually 3 does. So 1 and 3 are both intersections. So you actually have a set. This is actually a set of 1, 3 divided by, well, it's the cardinality of that, divided by B, which the cardinality of B was 3, which is equal to 2/3. Because there's 2 elements, which makes that cardinality 2/3. Now let me prove this to you another way. Let's make it more generalized. Instead of using this formula, let's generalize it a little bit differently. So we have P of A such that B has occurred, you're going to hear these terms, is equal to, now I'm going to write it out in this form, sort of. A intersect B, I'm going to divide this, just the numerator portion of it, by our sample space S, cardinality. All divided by, now let's take the denominator, B divided by S. So in other words, I just divided the top and bottom by the sample space S cardinality, which doesn't change the equation. I know it's hard to see. So what exactly is this now? Now what is B, the cardinality of B divided by the cardinality of S? So that is actually, in essence, the same thing as saying, now I'm working with the denominator here, the cardinality of B divided by the cardinality of S is actually considered the probability that B occurs. Simple as that. Now we have A intersect B all divided by S. So this is actually the probability of A intersect B. So your final form is this right here. So the probability of A intersection of B divided by the probability of B is the same thing as probability of A such that B definitely occurred. You see how they tie